All right, here we go. Let G equal this. What is the domain of G? Now, it's funny to me because I just had this conversation with Algebra 2 Trig, my Algebra 2 Trig students, but now I'm talking to my calculus students. Now, whenever you see a question like, what is the domain? It's asking the same question. It's saying, what can you plug in? So you look at the function and you try to figure out if the function has any limiting values to it, or limiting qualities, I should say. Values is more like a number. And so let's start on the inside right here. Is there anything limiting about this? Like when I plug t's into this, is there anything limiting about it? -4. Yeah, -4. Man, you busted out no time. And the reason is because of this square root. You guys see the square roots? What can you not have inside of square roots? You can't have negatives. And so you start thinking, if I plug something in that t right there and I raise it to the third power, will it give me a negative? And you think, oh, what about -2? I plug in -2, I get -8. -8 plus 64 is still a positive number. But I can pick a bigger number that will give me a bigger negative, right? Like -4. If I plug in -4, I get -64. -64 plus 64 is 0. Now, nothing's stopping me from taking the square root of 0, so I'm still safe. But if I pick -5, there's the problem. If I pick -5 and plug that in there, now I'm going to have a negative number inside of this square root. Am I allowed to have a negative number inside of a square root? Nah. So that's a limiting factor, or like a limiting quality of this function right here. But then you start working your way out, and you see this x squared right here. What does x squared do to numbers? It squares it. Yeah, but more generally, whatever I plug in the x squared, what's my result going to be? Positive. So will I ever plug a positive number into t? Or I'm sorry, will I ever plug a negative number into t? No, because whatever I put in for x, it's going to make it positive. Does that make sense? So that means the domain of G, all real numbers. All right, so now we have that. What is the domain of G? You wrote all real numbers. I'm not going to write it for the sake of time. B says, find the intervals on which G is increasing. When you guys are doing these FRQs, I'm hoping that you see over and over there's like a theme going on here. F, F prime, F double prime. You guys know those relationships. You know them. We spent lots of time with them. So let's think about that. Now we're not having F right here, we're using G. So let's think about G. We have G, G prime, and then G double prime. You guys know the relationships between these guys? You know, okay, this is our normal graph. What is G prime? That's the slope function. It'll tell you the slope at any point on G. Now, what else does G prime tell us about G? Someone's just said slope, which is absolutely true. But what does slope tell us, like how the G function is behaving? Slope tells us if the function is increasing or decreasing. Okay, like if G prime was negative, what is this one doing? It's decreasing. If G prime is positive, what is G doing? It's increasing. That makes sense, right? This is logical, very logical in calculus, okay? So this says, find the intervals on which G is increasing. Do we know what G prime is? Like we know what G is. Can we find G prime? Because if we knew G prime, wouldn't we be able to figure out if G is increasing or decreasing? Absolutely. So this is when we're going to take this and we're going to take the derivative of it. And when you take the derivative of it, you're actually using the fundamental theorem of calculus part 2. That's FTC2. Okay, you guys ready for this? So we need G prime. So I'm going to take that number 2 and I'm going to take the derivative of it. When I take the derivative, let's write it out. This is B. When I take the derivative as we go from 0 to x squared of this craziness, we have t to the third power plus 64, and that's dt. If I take the derivative of this, we know, because we worked on and understood FTC2, we know that all we need to do is take this guy and plug him into the t. Whatever is down here, we don't care about him because he is actually just a constant. In the long scheme of things, if we figure out the formula for this, we know that the 0 is just going to give us a constant, so he cancels out anyways when we take the derivative, right? Right. So we just plug in the x squared We're going to cube it, add the 64, and then square root it. That's the derivative of the integral parts. But look at what we're plugging into it. We're plugging in another function, so that means we have to do the chain rule. So not only are you essentially just canceling these out and putting the x squared inside of there, but now you have to take the derivative of the inside function, because that's what a chain rule says. The chain rule says take the derivative of the outside function with the inside function inside of it, which is what we have right here. There's the inside function inside of it, and you have to multiply that times the derivative of x squared. What is the derivative of x squared? 2x. That is g prime. Now remember what we were saying earlier? G prime, if we know where g prime is positive and where g prime is negative, we know where this is increasing and where it's decreasing. So what we're going to do is we're going to find the x-intercepts of our g prime by setting it equal to 0. I shouldn't say this, I shouldn't say this is equal anymore, because now I say it's equal to 0, but how would I solve that? Well, there's something called the zero property. You guys remember zero properties? The zero property says this: if you have two numbers multiplying together and you get 0, then one of those, just one of those, has to be 0. So what you do is you take each of them and you set them equal to 0. So I'm going to say, what is that? X to the 6 plus 64. You guys see where x to the 6 came from? Everybody's cool on that? It's you see x squared raised to the third. You multiply these exponents and you get x to the 6. You set that equal to 0. Then we say 2x equals 0, and then you get busy with it. The first one, we square both sides so that you don't have a square root anymore. And you have x to the 6 plus 64 equals 0. And then you move the 64 over, so now you have x to the 6 equals negative 64. And then you stop, because you know that if you raise anything to an even power, you're supposed to get a positive number. And look, I don't have a positive number, so this one's done. I can't do anything with that one. This one right here, I get x equals 0. So we only have one x-intercept for our g prime function. And so you draw your line. You're creating like a sine line graph, and you're trying to decide, is it positive or negative in this one, or is it positive or negative in this one? Because if we know if the graph is above the x-axis or below the x-axis, that will tell us if g is increasing or decreasing. So give me some numbers I can pick. 1 and negative 1. Now if you plug in positive 1 and plug in negative 1, you will see that this is negative right here and this is positive right here in that interval. That was a good question. What you do is you plug the 1 and the negative 1 back into g prime, because we want to know if g prime is positive or negative. So this right here is g prime, these guys. Because I took the derivative of this is g prime. I didn't even write that formally. I'm sorry about that. This right here is g prime. So you take the negative 1, plug it into g prime, and then take the positive 1, plug that into g prime, and see if you get positive or negatives. Now remember, you don't have to find the answer all the way. You just need to know if it's positive or negative. Okay? So we know it's positive between 0 and infinity. So that's what you say. You say it's increasing between 0 and positive infinity. That's your answer for letter B. All right, so let's look at C. All right, I think B was the hard one. Check out C. This is all C says. What is G double prime of 0? Whoa. Do you guys know how to find G double prime? Take this guy and take the derivative of him. Okay, so for C, we have to find G double prime of 0. That's not too integrally. All you're going to do is take what g prime is, which is what we wrote above. Let me clean it up here. X to the 6 plus 64, and that's multiplying times, I'm going to put parentheses around it, that's multiplying times 2x. That's g prime. You just have to take the derivative of that. Now, to take the derivative of that, you're going to need the product rule, because you have this guy multiplying to that guy. When you take the derivative of the first one, though, you're also going to need the chain rule. So you're going to have the chain rule inside of the product rule. Now, I'm not going to do this right now because I feel like this is last semester stuff, and you guys can spend. I don't want to take away your practice, and I want to talk about other things. So after you do that, then plug the 0 into whatever your result is, and then you will get your answer to letter C.